Hello everyone. Today we are going to see about a discrete uniform distribution. The discrete uniform distribution is one of the simplest distribution, and here in this discrete distribution in statistics we are going to find the expected value and variance. The uncertainty and expectations are the joy of life. So let us find the expected value and the variance of this simple, uniform, discrete distribution. And in a uniform distribution, the probability mass function, or the PMF, is denoted by P of x equivalent to x, which is 1 by n, where n is the number of possible outcomes, and this x is the choice of the outcomes in x. And this is reasonable because the total probability should be equal to 1 always. That is the property of a probability. When the probability of each case is 1 by n, and if there are n occurrences, then the total probability will be n times 1 by n, which is 1. So the probability mass function is defined by P of x equivalent to x, which is 1 by n. For example, let us take the case of rolling a die. And when you roll a die, you get the sample space. These are the outcomes. All possible outcomes are the sample space, and we have the sample space as 1, 2, 3, 4, 5, and 6. And in this case, n is 6. And we all know that the distribution table is given by this 1, 2, 3, 4, 5, 6, and each outcome has the probability 1, 6, 1, 6, 1, 6, and 1, 6. Before finding the expected value and the variance, we should recollect the two important identities in advanced algebra, where we get the sum to n terms, the sum to partial sums of the series, say 1 plus 2 plus 3, etc. up to n. If I add all the nth partial sum in a series, consecutive numbers 1, 2, 3, etc. up to n, then the total can be written as n plus 1 divided by 2. Or in general, I can say that it is of the form sigma k equal to 1 to n of k. And k is the variable here, will be n times n plus 1 divided by 2. The same way, the sum of squares of first n terms, that is 1 squared plus 2 squared plus 3 squared goes on up to n squared, will be n times n plus 1 times 2n plus 1 over 6. Or in general, I can say that sigma 1 to n k squared is n plus 1 2n plus 1 over 6. So we are going to make use of these two identities to find the expected value and the variance of this uniform discrete distribution. First one is the expected value, and we are trying to find the expected value. We know that if x is a variable given by, say, x is 1, 2, 3, etc., and goes on up till n. You said the probability of x equivalent to x is 1 over n, one by n, etc., 1 by n. And the expectation of x is the sum of the products x and p of x. So you have sigma 1 to n, x 1 by n. 1 by n is a constant, and sigma 1 to n x is n plus 1 by 2. When you simplify, you get the expectation of x to be n plus 1 over 2. When we want to find the variance, the formula to find the variance is expectation of x squared minus e of x the whole squared. We have the two results from the previous expectation. Expectation of x is n plus 1 by 2 the whole squared. But what is expectation of x squared? So we have this x squared as 1 squared, 2 squared, 3 squared, goes on up till n squared. And the probability of each x is 1 by n, 1 by n, 1 by n, 1 over n. So the expectation of x squared will be the sum of these products. 1 squared 1 by n, 2 squared 1 by n, 3 squared 1 by n. So expectation of x squared is sigma x squared p of x, which is 1 by n, sigma x squared, which is 1 by n, x squared is n, n plus 1, 2n plus 1 over 6. Or that is n plus 1, 2n plus 1 over by 6. So that's what I have here. Then when you subtract, you get the final result as n squared minus 1 over 12. So in this video, we found the expected value and the variance of the discrete uniform distribution. That's all in this video. Thank you for watching. Thank you.